My name's Roger Simons, and again, I'm the branch chief over the National Science Laboratories. Um, a long time ago, back in 2006, we started testing pesticide residues in apiculture samples. At that time, it was pollen, some bees, and we were working with Penn State University. Chris Mullen, Marianne Frazier, and it was a really exciting time. And we've so that's been 15 years now. We are still going strong, still participating in a lot of um, many studies. We have a pretty broad range of clients that send us samples, but the National Honeybee Survey is one of our most important, without a doubt, one of our most important clients, and we've done work for them for many years, and very much so value that partnership, and take don't take it lightly. We feel like we provide as good a service as we possibly can, and I'll say this about, and I'm sure John might mention this too. Uh, so John is he's the laboratory's the chemistry section supervisor, and he oversees the day-to-day operation of the lab, of the actual analytical part of the laboratory. And but honeybee matrices in general, if I can just start it off like this, are very challenging to work with. They're not like a fruit or vegetable that's mostly water, and it's pollen is probably one of the most complex substances in the world, and it causes a lot of challenges analytically, uh, to be able to extract pesticides from it, and also remove a lot of the co-extractants that we get from the pollen that could interfere with observing the pesticide residue. So our people, John's going to show a slide of the team that we work with. They've worked over the years tirelessly to try and tweak our methodologies to be able to work really well in finding pesticide residues. Wax is a really difficult one. I hope we never have to do propolis for you guys. Propolis is a nightmare to analyze, and we currently are doing some propolis for another research group, and it's extremely nasty matrix to try to analyze pesticides. But we feel like we over the years we've gotten pretty good at analyzing. We've been able to hone in on doing pesticide residues in honeybee type samples. So yeah, and I want to just hand it over to John. I don't want to dominate the conversation. I want John to get into what we actually do at this lab. But I did want to touch on that. We've been doing this for now 15 years, and when we started, I was in a lab. I was the guy running the GC and the LCs, and now I'm not, which I actually miss that. But anyway, we have a great team, and John's going to talk about them.
All right, welcome everybody. Can everybody see my screen? Do you see the presentation?
Yes.
Okay. All right. What we're going to do is we're going to give you a kind of an overview of what goes into everything that we're doing, so that you get an understanding of the process. Okay. So first, we're in Gastonia, North Carolina, and there's a picture of our laboratory. Whoops. I wish it wouldn't do that. Anyway, we have 28 employees and 4 disciplines, and I don't know why it wants to advance by itself. I asked it to turn the thing off. So hang on just a second, please. So I'm going to go with it in this direction. All right. We're going back here to the Gastonia, and there's four, like I said, there was 4 different disciplines: residue chemistry, food chemistry, microbiology. Then we got microbiology and molecular biology. So those 28 employees are not all scientists. They're not all analysts. So typically for chemistry residue, there are probably only right now about 11 people doing all the work for the chemistry section. So next, here is our chemistry residue group. Marie Densky, who sends out most of the reports and does a lot of the review. We have Greg Franks, who receives a lot of the samples and works with Kendall Torres over here to set sample sets up and then get them extracted for the chemists, one of whom is Mike Lyons, the other is Richard Reaver. Richard works with the gas chromatographs, and Mike works with the liquid chromatographs. So they have to have a support staff. So our support staff's almost as big as our analyst staff. So we got Roger, we got myself, we got Ben Goodes, who receives the samples when they come in the door and then distributes them to Kendall and Craig, who you just saw. And then Brian Stogner, who works with our laboratory information management system. And then Raphael Karenbach, who is our IT, another IT specialist. And the work we do would not be possible without these 3 gentlemen right here. So. All right, so this happens to be just samples when we receive them. So say when Rachel sends them in, we'll get them in a box. There is a sample information form, and on that sample information form, it tells us what we need, how we're supposed to test each different sample. And therefore, then we open up the rest of the box. We reconcile what's in the box versus what's on this piece of paper, and then make sure that all the samples are acceptable. If not, or if there's any discrepancies, then we have to communicate with whoever sent us the samples to make sure that we know exactly what to do and what's going on. All right. After everything's reconciled and we've logged it into our laboratory information management system, then we have to prep our samples. Many of our samples we send through a freezer mill or use dry ice to homogenize, because you can imagine how to homogenize wax can be difficult. So if we freeze it and use it in the freezer mill, which is, this is one of them right here in the background. It's done by liquid nitrogen, so it freezes it, and so we can turn most things into a powder. Therefore, as it's homogenized, we take a subsample of that, and then we analyze, we extract, and analyze. All right, after the prep, then we have to weigh out the samples. So this is a setup here that Greg used. See, this is probably pollen down here. spread. So then we put them in these tubes. And then the tubes we weigh in 3 grams because our method is validated at 3 grams. So we have to use a constant weight to be efficient with our work. And that way we're not always having to change all sorts of parameters or solvents or internal standards or process controls amounts. All right, these samples are ready for extraction, solvent addition. So you can see a set over here. So we're usually trying to get sets of 20 or more. Wax, we have limited to a sample set of 20 because of the length of time it takes to actually extract and process the sample before we can give it to the analyst to place on the instrument. So this shows that the solvent has been added in here, and then it's homogenized. We put it on what we call a Geno grinder. It's you have your sample in there, then we add the solvent, then we add some salts, and then a grinding wedge, and then we shake it. It's like almost a glorified paint shaker, but we can do multiple samples at a time. Then after that, then they take a portion of that and move it into 15 ml centrifuge tubes to begin the process of sample cleanup. Our samples will run through a SPE cartridge. That's a solid phase extraction cartridge, so that we can get a lot of the matrix out of there. But as you can guess, pollen has a huge matrix to deal with. There's no 2 pollen grains are the same. So once it is goes through this column and is collected in the tube below, you can see the tube below contains, looks like it's a little bit white powder. Yes, we have a material in there that's anhydrous magnesium sulfate to help dry out the samples, because well, the instruments, or the GC instruments, cannot handle water. Therefore, we have to keep them as dry as possible. So after we're done there, the samples are then placed into a evaporative system, which we will reduce or blow down the solvent so we can concentrate the liquid so that we can have our lowest possible limits of detection. So Kendall always works to get them all down to the same volume. So here's Kendall actually performing some of the work. You can see the tubes. This is a positive pressure manifold. So then he's also working with Craig over here. This is one set of evaporation devices, but this is the one we use the most up here in the top right-hand corner, because it seems to be the most efficient and it does the best job and gives us results that are the best. So our residue team not only does stuff for apiculture related, but we also do environmental for APHIS. We also do pesticide data program, national organic program, and researchers from universities. So once that prep is finished, the material is transferred into small vials and given to the analyst to place on the instrumentation. So we're talking, the sample gets blown down to only a few mLs and split between 3 different instruments. So it's all it's a challenge. And then their samples are injected into the instruments where data is collected and then it's reviewed. So here's some of the instrumentation from our GC analysis. This is a view of our GC laboratory. Actually 3 views. The instrument right here, to the left in the top left picture is the gas chromatograph. It's a mass spectrometer with a negative chemical ionization, so NCI. That does a really good job for some compounds, but not all. Therefore, we have to also use the one in the upper right-hand corner, which is gas chromatograph, which is a mass spec, some people call it triple quad. So we look at other things. And these are the ones that are gas volatile that do not necessarily can be detected by a liquid chromatograph. All right, this is our LC laboratory, and we have several mass spectrometers in the LC laboratory. 2 of them are used almost extensively for pesticide residue analysis, and that we move back and forth as we need to get the work done. Then after the samples have run on the instruments, by the way, each instrument has to have a set of calibration standards. And so if we have a detection, in order to quantify it accurately, the detection has to be within the calibration curve. If it is less than the calibration curve and it's, we can see it's there, but it's not really quantitatable, that's when you may see the term trace on a report. However, if there's a detection that is higher than our calibration curve, then we have to do an additional analytical work by diluting the sample so that we can get the detection within the calibration curve to give an accurate result. So that falls on the chemists to do that, and sometimes it's very arduous. We found that pollen had a lot of detections, but wax had even more. So it can take quite a bit of time to be able to analyze and provide results for some samples. And like I said, our analysts, they look for the pesticide detections, and there are approximately 200 pesticides in the stream at this time. Once they get finished and the data has been reviewed and there's no other questions, then we send out a report. And the reports would look something like this, of all the different compounds that we were looking for, and what the result was if we saw it or if we didn't. So if we didn't see it, it's usually listed as ND, non-detected. If you can see it, but it was below what's quantitatable. Then we listed as trace, and then the others are listed as their numeric value for the detection. So if we receive samples that have enough sample, in other words, there's a sample left over after the extraction, then we typically store them in our freezer room, and we hang on to those samples for 14 days after reporting to our clients. Because we don't have enough room to store many things for very long. So that's, this is a picture of our freezer room, and we have that holds for chemistry alone. Microbiology has their own freezer room. So we have both food chemistry and residue chemistry samples, but they are segregated by designated refrigeration units. So this is just kind of like a little overview of the different things that our team looks at. Yes, we've done peanut butter. We did that for the pesticide data program several years ago. So we've been doing these samples for apiculture testing since around 2006 or 2007. And so we've been doing this for quite a while. And as Roger said, he was one of the ones doing the testing to begin with. So had great leadership from him and know how to get things done. There are some other things that we do for honey testing. We can do antibiotics, heavy metals, dietase activity, HMF, sugar profiles, and glyphosate. We also do honey adulteration, and I'm going to let Roger speak to that since he's been working with that heavily in the last 2 years.
So yeah, thanks, John. I just want to really touch on that. We're going to get to the questions that you guys submitted in a minute, but as John said, over the last 2 or 3 years, we've really began a focus and an effort to outfit our laboratory to perform adulteration testing. And as I'm sure you guys all know, honey adulteration is a huge issue worldwide. And there actually aren't a lot of labs in the United States that provide testing for this. There are several labs in Germany that do, and the German labs do a fantastic job. Just they're incredible. But we had enough people amongst our stakeholders, many of whom we've met through pesticide residue work, that kept requesting us to be able to do adulteration testing. So we have had for the last 2 years, we have a couple of isotopic ratio mass spectrometers interface with LCs and elemental analyzers operating here at the lab, and we can test honey for adulteration using a technique developed by Lutz Eflin. He's currently with Eurofins. You can look for C4 adulteration. It's very, very good at finding C4 adulteration in honey, which would be cane or corn sugar syrup. And it can also, it has limited sensitivity, but it can detect C3 sugar syrup addition as well. So we currently provide that service here and have several clients in the honey industry that utilize our services for that testing. But another thing that we're adding that I'm super excited about, I wanted to share real quickly, is this year we were able to purchase a high resolution mass spectrometer with an LC. The instrument is actually an Orbitrap. made by Thermo Fisher. And what it will allow us to do is it's the newest emerging technology to detect honey adulteration. And I think it will end up being the best technique of all the other ones out there. Many of you have probably heard of NMR, nuclear magnetic resonance. It's another technique for detecting adulteration in honey. It works. It's a good technique. I have no problem with it. It's just difficult. It's a very difficult assay to begin using. It cost $1 million just for the instrument itself. And it's not really what we do here, but we do, as you, John has shown, we do mass spectrometry pretty well. So basically what the high-res mass spec does, we can take sugar syrups that we are in process of getting. We're getting some sugar syrups that they actually use to adulterate honey with, and then just general honey. You can go and buy rice syrup or beet syrup or other types of syrups, and you test them, and although they can produce syrups, fructose and glucose syrups that are very similar in nature to honey, when they process the plants to produce the syrups, they leave behind residues that come from the plants, and these are called marker compounds. And the high-res mass spec is so sensitive, it can detect the accurate mass of these marker compounds. And then we analyze pure honey samples, many pure honey samples, and you get a profile. You identify there's about 30,000 different compounds you can identify in a honey sample, and then there's another group of compounds you can identify in sugar syrups. Many are the same, but when you overlay the two, you will find compounds that just occur in honey, and you will find compounds that just occur in the sugar syrups and never in the honey. And you can utilize those compounds and their accurate masses and calibrate your instruments to look for those, and you can detect honey adulteration. And that's what we're currently doing. We hope to have that service operating in the fall, and I really think it could be a huge benefit to, and I know there are APR inspectors here that this might be of interest to. But we're also, one other little plug I want to put in before I hand it back to John is that we're trying to find sources of pure honey. And I've reached out through several avenues to, and thankfully I had through the National Honey Board, through ABJ, and different ways of reaching out to folks. And I've had several people, volunteer to help us work through that. But if anyone knows, some sources of we could get pure honey from for our work in this honey adulteration, it would be super valuable and appreciated by us, and we can pay for any costs for that, for those honeys. But if anyone has any interest at all in that, I think John and my emails will be posted somewhere, so you can please reach out to me directly, and we can hopefully get some honeys from you. And I just got a chat thing, so yeah, if hopefully we can have our email address out there. Maybe John can put it at the end, and you guys can write it down. So
it's there, Rodney. It's there. Okay,
awesome. So yeah, just wanted to put a plug in for that. Sorry for taking a little rabbit trail here on adulteration, but that's kind of what my focus and passion is right now, and John's taking care of the pesticide side of things. So John, I'll hand it back to you.
All right. Now, Rachel provided us with some questions, so we thought we'd go ahead and put them as part of the presentation, so you could have see the answers. Let's go to question number one. How much of each sample is considered adequate for analysis? Right? Well, we use 3 grams weighed into a conical 50 ml centipede tube. That's what is sufficient for running an extraction. Okay. What equipment is used? Well, quite a bit of different, the homogenizers we use are like $24,000 a piece. Then you have micro pipetters that, and the digital ones are like $300 to $600 a piece. Then you got your instrumentation. So these three sets of instrumentation right here are in the neighborhood of probably $700,000 for the ones that are listed here and other pieces of equipment. So we're well invested into the various different equipment needed to do the analysis. How long does it take to run a sample? Well, it depends on the number of detections, on whether dilutions must be made or sample re-injected on one or more of the instruments. And also the number of samples in a set. So that's a moving target based upon the samples and the number of samples in the sample set. If we were to take a single sample all the way through, we could probably, and everything lined up on the in the calibration curve. We could probably do it in three or so days, but that's not a very efficient use of time, because that means our price would have to skyrocket, because then you've got all the injections for all the standards, and you've got another sample called a matrix spike sample, which we spike onto a matrix spike, which has got all the compounds in our stream, which we put onto another sample, and then we have to recover all of them at an acceptable level. So the amount of QC that goes into our testing is pretty significant. Okay, LOD. How does this compare to other labs? Well, we don't know. We don't go around comparison shopping. So we don't know what other laboratories are doing. We just try to take care of ourselves and do the best job we can. Is the lab ISO accredited? Who certifies USDA labs? Yes, we are. A2LA is our certifying or accrediting organization. Is the sample kept after processing? Yep, there we go. If there is any sample remaining, yes, for 14 days after reporting results to the customer. Does this ruin the sample to run it? Oh yeah, because we're adding solvent to it. So the sample is not in the same form. Which we've had people in the past say, can we send it to you in alcohol? And we say, no, please, because that would mess up our test, because then you've already dispersed some of the pesticides into the alcohol. All right, let's go to the next page of questions. How often do you review or update the list of targets? The list has only been established twice based on stakeholders' requests and re-input. How do they update? Okay, do they meet periodically with EPA to see which products are in use or new to the market? Well, the last time that it was done, Roger worked with EPA and the major stakeholders like National Honeybee Survey. Because to reestablish the list, it's a major undertaking. When you go to validate the method with new compounds, it takes at least, if everything's efficient, a couple weeks to a month.
John, I'd like to interject something right there.
Sure.
But having said that, we're open. You know, what we need ears and eyes from the people we serve. You know, if you guys hear of things that could potentially be a problem,
Right.
You guys are our source of information about really what needs to be looked at. I mean, we have chemicals that we routinely test for, they get added for NOP or PDP or whatever. But we like to collaborate. It's a partnership. We look at it as a partnership with our clients. So if you guys see something out there that you think would be relevant for us to add to our screen that we don't currently, please contact us. We're very open to suggestions and dialogue and collaboration. And again, we try to treat our clients like partners, and we would like, in reciprocal way, you guys treat us like partners.
Right, so that kind of goes into that next question: what additional chemicals are being considered to add for future surveys? Well, we analyze for chemicals that are requested. So that is our function as laboratory. Our function is not to create the list, but to work with the stakeholders. Are higher than normal expected nicotine levels being checked for, or is that even a concern? Now, is that, I wasn't sure if we were talking about nicotine or neonicotinoids. We don't check any samples for nicotine, but neonicotinoids are included in our apiculture pesticide stream. If your cost was not an issue, what else would you look for, and how much more would that cost? That would probably be a question for stakeholders like National Honeybee Service. Because what we try to do, we try to be as efficient with the testing to as we can. So all the compounds that you're seeing on that report I showed you earlier is done by one extraction. But in cases like, say, glyphosate, if we were to ask to be look for glyphosate, it's a totally different extraction. So it all depends on what compounds are being asked for, if they require a separate extraction, and because each extraction and analysis carries its own fees based upon its complexity. Is there a way of making this cheaper? A beekeeper top 10 list panel? Maybe. Haven't considered it, and it also will depend on what compounds are being requested and how many different instruments may be required. So, like when we run we do a miticide screen. Well, it's already requested. It already takes 3 different instruments to run just the different miticides. So. But if it were compounds that were only on one instrument, yeah, it could, if it's a 10 panel list, could be a reduction in cost. It all depends on what compounds are being requested. What are the most critical elements that would affect the outcome of the diagnostic that we should know about when sampling and shipping? Okay. Sample integrity and packing of samples so that they do not get damaged or contaminated during transit. So that's critical, because if they get contaminated or damaged, then the results of that test for that sample would probably not be very useful. Is it imperative to store samples in certain containers for analysis, i.e., have they tested other storage containers to see if they work as well? Yeah, other containers work fine, especially glass, except for when involved with glyphosate. When we run glyphosate, we have to have as little glass as possible anywhere, because glyphosate tends to adhere to the glass, and therefore may not get the result that you're looking for. if 50 ml centrifuge tubes are not used with a weight of 3 grams, then a larger amount of, greater than 10 grams of sample is required. And the reason we ask for, if you only have a limited quantity for 3 grams weighed out already, is that way we don't lose any sample and transfer from one container to our extraction container. Let's see. If y'all can address that, we extract the samples in 50 ml centrifuge tubes to save time and keep processing times to a minimum and reduce loss of samples during transfer. What do they recommend we do differently if necessary if a beekeeper wants to use their samples for litigation purposes? How does AMS get involved, or do they? As a service provider, that's how we get involved. We produce defensible data that can be backed up with QA/QC data. However, we are not a regulatory agency, and the samples are not official in the sense that we would be involved in a litigation. That would be totally on the beekeeper. What trends are they seeing in detections? More detections per sample? This is sample type dependent. Pollen and wax are the 2 matrices that have the highest number of detections and the highest amount detected. Other levels of certain products, and if so, what ones? Well, the thing we see a lot is basically the miticides, the things that are actually introduced by the beekeeper, whether it be fumifos, fluvalinate, thymol, or the metabolite of Amtraz, which is a compound called 2,4-DMPI. How many bee-related samples do they process each year? Well, last couple of years, not so much, not as many, but prior to 2020, the lab analyzed an average of greater than 2,000 bee-related samples per year. Do they process beekeeper submitted samples? Yes. Yes, we do. Are they able to share data on their yearly sample processing? The data, well, the client owns the data, not USDA, because they paid for it. If data is to be shared, it must be initiated by the client. They are the ones who are paying for the testing. Are there results that surprise you? Well, not anymore. All right. Okay. And okay, we can ask more questions, but right here is the contact information for both Roger and I. So, and then I guess we ought to, have you looked at the chat, Roger?
Yes. All right. I'm going to reply. Thanks for the, thanks. I appreciate everybody. I did want to say one other thing about the question about data. So we have, we are obligated to not distribute data under a confidentiality agreement. It's part of federal law. So as John pointed out, if and I, you know, and our clients like that. You send data, you send samples, we give you the results, and we're not giving them to everybody, you know, under the sun. So, but we have in the past in situations, you know, gotten, you know, been cleared to share some data, but it's totally up to the client to it's their data. They can share it if they want to.
Thank you so much, Roger and Jonathan. I really appreciate you speaking with us today. Right now, does anyone have any questions? If you do, feel free to either drop them in the chat for Roger and Jonathan, or you can unmute yourself and ask them on speaker too. Okay, I think you answered all of our questions. Thank you for answering all the questions that I submitted ahead of time. And yeah, that was very thorough. And yeah, for sure. If anyone has questions after this meeting, feel free to either forward them to me or Jonathan and Roger. Are you okay with everyone here reaching out to you?
Absolutely, absolutely. I just want to, reiterate, we very much so are very honored and are, value the relationship we have with the National Honeybee Survey. It's been fantastic, great working with everyone, and we hope we can continue to do that. And we're always open to feedback. That's the thing about communication. If there are some issues, we look at ourselves as partners. So we can figure out together if we can provide, if there are any ways we can provide a better service. We're constantly trying to make improvements here. We're making improvements in IT to become more efficient. We're trying to improve our instrumentation constantly. We're always trying to do that. And something was mentioned about cost, and we really do try to, since we're the U.S. government, we're a user fee agency, we try to operate on cost recovery. And honestly, with the pandemic and 2021, the year of the price increase, that's a struggle for us. So it's a really expensive chromatography instruments. Mass spectrometers are really expensive instruments, and they're expensive to maintain. So the pricing isn't because we are trying to make money. It's just that's really how much it costs to operate.
Thank you. And I just wanted to say too, thank you for doing all the work in validating honey, looking for the adulteration. I know that will help beekeepers a lot, because that's been an issue for a long time. And yeah, that's really exciting. So I don't know, I can't speak for everyone, but I'm really excited about that.
Absolutely, too. And I know a lot of people in the industry are. And again, in this group right here, if you guys, if you end up someone having a need for that, we provide the testing. And I really honestly think once we get that high-res mass spec assay going, when we couple the C3, C4 tests we currently do with the HRMS, it will be a pretty solid test, and be able to, I feel like, pick up adulteration from any source. In Europe, they really cut down the number of adulterations detected in 1 year after they implemented HRMS. I think they had like 35, the first year they implemented, they had like 35% of the samples were adulterated, and by the next year it went down to 15. So, we're hoping to really, just word of mouth. You guys, if people are struggling with dealing with adulteration, sometimes it's even a local issue. We provide testing.
Thank you. Thank you everyone for attending. Thank you, Roger and Jonathan. I really appreciate you taking your time out today to speak with us. And thank you for all that you do for the National Honeybee Survey and all the pesticide data that you provide for us. It's been really eye-opening for us, even just the difference between bee bread and wax and a number of detections has been really interesting and informative. So thank you both. And thank you to everyone that works at the lab that really gets, makes this possible for us. So yeah, thank you. And everyone, I hope you have a wonderful day and talk again soon.